enrolled in high school and two-year college. Mrs. Farley will be speaking a little bit to Mu Alpha Theta as a national organization. So I want to take a little time to talk about our chapter here at UHS. The requirement for admission to our chapter is a minimum 3.6 grade point average in math classes that students have completed. And that grade point average is unweighted. Students must also have completed Algebra 1, Geometry, and Algebra 2. And to be sure, these students have earned this honor of being inducted into this organization. My fellow math teachers here at UHS truly challenge these students and have nothing but the highest of expectations. So it is quite the accomplishment to have succeeded at such a high level at this school. Our chapter currently has 32 members, and our biggest endeavor that we undertake is our after-school tutoring program, which some of you may have heard about. Our members act as tutors once a week after school, and they assist their fellow students with any math with which they are struggling. It is really a joy to watch these students act as leaders and jump right in to help a student in need, and they have really made this a very successful program for our school. Mu Alpha Theta is very special to me. I've kind of helped out with this ever since even I was a student teacher here with Mrs. Plumpton, so it's something that is really important to me. And now this is my second year as the advisor. The true enjoyment I get comes from the experience with the students. It is so exciting to honor them for their achievements. And it's also great to see students, some who I see in the hallways, and some who now, since this is my third year teaching, who I have in class, it's great to see their hard work pay off. Inductees. My challenge to you is to uphold your high standards that you have for yourself, and always strive to meet the expectations that your teachers have for you, your parents have for you, and that you have for yourself. I also encourage you to consider becoming a tutor. I think that it can be really beneficial for you. It's definitely beneficial for the students of the school. So I really want you to think about doing that. It'll be amazing what a difference you can make in someone's math knowledge. Congratulations to all of you, and keep up the good work. It is now my privilege to introduce Mrs. Farley, the head of the math department here at UHS, to say a few words on behalf of our principal, Ms. Burgess.
Ms. Burgess asked me to send her regrets this evening that she could not be here. She had a family emergency. And so she asked that I share her remarks for her. So it is my honor to be here tonight on behalf of Mrs. Burgess to welcome the most recent inductees into the University High School chapter of Mu Alpha Theta. She congratulates these exceptional students on their accomplishments and shares their family pride in the induction to the Mu Alpha Theta Mathematics Honorary. Tonight, these students meet the guidelines set forth by Mu Alpha Theta in terms of their keen interest in mathematics, their strong scholarship in this content area, and their genuine enjoyment of the subject. Let's take a look at this organization to which you now belong, Mu Alpha Theta, which was founded in 1957 by Dr. and Mrs. Richard B. Andre at the University of Oklahoma. In their words, Mu Alpha Theta is an organization dedicated to promoting scholarship in mathematics and establishing math as an integral part of high school and junior college education. The name Mu Alpha Theta was constructed from the Greek lettering for the phonemes M, A, and TH. Mu Alpha Theta has grown to include over 88,000 student members in more than 1,800 schools. It sponsors a national convention that brings together hundreds of teachers and students from across the country for 5 days of math-related events. The organization makes several awards to outstanding students, to outstanding sponsors, to students who plan to become mathematics teachers, and to chapters that have shown outstanding service to communities. In 2006, the organization began offering merit scholarships to outstanding members. Ms. Burgess wanted to tell you these things in hopes that you'll pursue these opportunities and awards that are now available to you as members of Mu Alpha Theta. With achievement comes opportunity, and you've demonstrated that you are academically worthy to pursue many scholarships and awards. Based on your presence here tonight, Along with Ms. Burgess, I guess you have a love for math. Do you realize that great thinkers can't even agree on a definition for mathematics? Aristotle defined mathematics as the science of quantity, and this definition was accepted until the 18th century. With emerging theories and abstract topics, philosophers began to pursue a variety of new definitions. To this day, there are many definitions of mathematics. There is also a debate as to whether mathematics is an art or a science. While there seems to be dissension as to what mathematics is, Ms. Burgess does not think that there is more dissension about how effectively applying mathematics in our daily lives naturally unlocks opportunities and understanding in other areas. The honored students we have before us tonight fully understand the relevance of mathematical applications. They've asked their teachers since early elementary to explain how they are going to use what they are learning in math class in their daily lives. They've demanded answers, and they have developed an innate curiosity that compels them to explore how mathematics is used in life. You see, math is not just about the numbers. It's about understanding the relationships, the complexities, the abstract that allows one to demonstrate excellence in mathematics. It's about understanding those connections between the abstract and life. It's about understanding the process, not just circling the final answer on the paper. Mathematics provides order. It provides systematic solutions to problems. It allows patterns to emerge that reflect beauty. And mathematics allows the trained mind to logically resolve things that are abstract and difficult. Mathematics, when applied by students with an excellent understanding of mathematical concepts, an interest in the subject, and a genuine enjoyment of the subject, can provide real opportunities for future success. These inductees are inspiring to others and should be seen as role models in terms of their mathematical achievements. Tonight we honor you and we celebrate your achievements. We look forward to your future achievements. Congratulations, new inductees. You're a wonderful representative of the excellence at University High School. I had no intention of speaking tonight. I thought I'd be sitting out there, but because I am up here as the head of the math department, I just want to say what a true pleasure it is to work with such a phenomenal group of teachers who truly are one of the huge reasons that each of these young individuals is inducted into this honor society. So I couldn't be more proud to be a part of that department. And I want to give a special thank you to Sean Freeland, who's done an awesome job with keeping Mu Alpha Theta running at UHS. He's doing great things, and we're all really proud of him.
I'm so excited. I'm so excited to have Dr. John Boyer, Professor of Mathematics Education at West Virginia University, here to speak tonight. I took her class in my 5th year, my graduate year at WVU, and the class was problem solving in mathematics, and actually I took it with Mr. Alvaro here. And I heard that, if you get a chance, take her class. And little did I know that was the best advice I could receive. She is really an inspiration to me. She helped me to develop a clear vision for my teaching and for mathematics in general. In that 5th year, I had already finished my math degree, so I'm thinking, what could I get out of this that I don't already know? I'm thinking about that. But I never thought she could change the way I look at math. And it has really positively affected my philosophy of education and the way that I teach. And hopefully that has helped me to instill some problem-solving skills, some critical thinking skills in the students that I have now. So it is my privilege to introduce Dr. John Boyer.
Well, thank you, Mr. Freeland. I will say that I have been very blessed to have wonderful students, including Mr. Alvaro. So when you have good students and they're inspiring and they're excited about what they're doing, it really helps you kind of do your job well. Congratulations to everybody, all the new inductees and all the different members. It's wonderful to see so many people who are interested in math and clearly who are doing well in the subject. So, sort of echoing some of what Ms. Farley was talking about earlier, I'm going to kind of keep with that theme of what does it really mean to do math? Is it getting an answer? Is it following steps? much, much more. So usually when we say to people, what's math? Or what's it mean to do math? For most people, the answer they're going to give you is addition, subtraction, multiplication, division, computing, getting an answer, finding x, right? For a lot of people, that's like a dreaded thing, to find x. But if we really think about mathematics and the way that people who really use mathematics use it, they don't focus on following steps to find an answer. They use it to explain, they use it to predict, they use it to create, they use it to model. So really, we want to kind of think about this broader view of what mathematics is. Otherwise, we're really limiting ourselves and really limiting the possibilities of what we could possibly learn and understand. So I'm going to argue that actually mathematics is more study of patterns. It could be a tool, it could be a language, it could be an art. So if we think about this broader view, we really sort of find different ways that we might enter into mathematics and become doers of mathematics. This broader view is actually one that the Writers of the Common Core, which is something that West Virginia has joined, they've joined that coalition, this is something that we're doing, sort of adopted and they embraced this and they put this into the writing of that document, and they did it through what they call the standards of mathematical practice. Now, these are things that they talk about, these are habits of mind. These are dispositions that students should develop, K through 12, and that they should engage in mathematics in this way. And to me, that word engage is really important. So I want you all to think about that for a second. If you're engaged in something, you're not just sitting there having it done to you, right? You're part of it. And I think this is really part of that broader view of what it means to do mathematics. You're part of the process. So the things that they talk about here are things like making sense of problems, persevering, communicating, arguing about your reasoning, modeling, looking for patterns. And these are the things that real mathematicians do. These are things that we want everybody to do. The amazing part about it is what we figured out through years and years of research is that with this broader view of mathematics, we give access to more people. You know, we have this idea that math, you're a math person or you're not. And frankly, there's no science to back that up. There's no gene, right? So if we have a broader view of mathematics and we let people engage in it in multiple ways, what we found is that people can actually have more access to it. People who thought they couldn't do it before can do it. People who thought they could only do certain things with it find out that they can do more with it. It expands your understanding. It expands where you can go. So I think this broader view is something that we finally started to recognize and say, hey, we've really got to do something about this. And I want you all to really kind of think about that for yourselves. Clearly, you have some abilities when it comes to math. But I want you to also think about, could I expand those? What else could I do with this? So, let's kind of just think about a little example. One of the things I mentioned was making sense of problems and persevering in solving them. So when we think about that, what we think about is what you think it means to do math. Understanding that it means to solve problems, explain them, and look for better ways. Look for more efficient ways. I solved it this way, but maybe I could do it another way. There's a lot of science about, research about cognitive abilities that sort of back this up, that good problem solvers know what they do, they know why they do it, and they can self-monitor. So these are things that everybody should develop. The interesting part about that is it could probably help you in other areas, not just math. So I think this is probably a good habit of mine. Let me give you a problem. It's what, 7 o'clock, it's been a long day, it's cold, it's snowy, so we're just going to make it a simple one here. I want you to think about this problem, so we can kind of get a sense of what math could be other than just producing an answer. You multiply two numbers together, and the product is almost 400. What could those numbers be? Think about that. I'll say it again. You multiply two numbers together, and the product is almost 400. What could those numbers be? I'm going to ask you another question. Are those the only two numbers that they could be? And could you find two numbers that would even get you closer to 400? Turn to the person next to you and just chat about lots of things. Some possible answers might be, somebody could say, well, I know 1 times anything is itself, so I said 1 times 399. That's 399, that's pretty close to 400, right? Somebody else might say, well, I know 9 times 4 is 36, so I thought about 9 times 40 and got 360. That's pretty close to 400. Somebody else might say, well, I know 20 times 20 is 400, so I'm just going to change one of those factors to 19 and do 19 times 20, and then I get 380. So all these things are possibilities that students could think about if they're working on this problem. Now, I could maybe ask them questions like, and this is probably a 4th grade maybe task, I could maybe ask them questions like, are there other numbers that would work? For the student who got 19 times 20, I might say, could you find anything closer? And then they might find out that they alter both factors, the 19 and the 20, or the 20 and the 20, and make it 19 and 21, they do get a little bit closer. So the way this is written, clearly the focus is not producing an answer. This is engaging students in mathematics. You're thinking about what you know. You're thinking about multiplication. You're thinking about what does almost 400 actually mean. You have to make sense out of that. You can find one set of numbers that would work, but then you can find more. You can find something that looks pretty good, and then I might challenge you to find something that's even closer. So you're drawing on much more than just following steps. Now, on the other hand, if I'd said to you, okay, we're going to do this problem, and I know 20 times 20 is 400, so I'm just going to change one of the factors to 19. I get 380, and that's pretty close. Now you guys find 2 more. You're probably just going to do exactly what I did and keep switching those numbers and multiplying and say that's pretty close. But you haven't really thought about what mathematics is. You haven't really engaged in doing it. So if we only focus on doing steps and getting answers, we're missing so much. So what does it mean to do math? For my thinking, what I know about research, what I've read, what I've seen, it means not just knowing what and how, but also knowing why. It means not just performing steps to get an answer, but also understanding the relationships, thinking about why those steps work, and do they always work. It means not being a passive learner, not having math done to you, but being somebody who produces mathematics, somebody who produces ideas and produces understanding. So, my challenge to you is, I want you to think about, where do I fit when I think about these habits of mine? Making sense of problems, communicating my thinking, reasoning abstractly, modeling ideas. Where am I? And challenge yourself to sort of expand the wonderful ability you already have to deepen your knowledge about mathematics. Also, I'm going to challenge you to do the same for others. Maybe they haven't had an experience like that, and that might be holding them back a little bit from reaching their full potential. Help them see that it's more than just spitting out an answer. Help them see the beauty of mathematics. Thank you.
Hello, my name is Grant Gutman, and I'm the president of Mu Alpha Theta here at UHS. Now we are going to introduce the new inductees and present them with their certificates. So if you just want to come up on stage here as I call your name. First we have Amanda Ackerman. Richard Beafor. Caitlin Brand. Amanda Katharina. Anthony Chen. Sydney Klingerman. Fred Daring. Jeremy Eccles. Emily Elkins. Bradley Furka. Anthony Frisco. Addison Griesbaum. Rachel Gano. Madeline Harvey. Emily Huff. William Howard. Christopher Jackson. Teresa James. William Johnston. Justin Jolliffe. Caitlin Keener. Ryan Kerwin. John Kolar. Madison Kroger. Madison Kakura. Kendra Lobbin. Addison Martin. Tara Meek. Jordan Miller. Matthew Menard. Abigail Mitchell. Daniel McNeil. Addison Nordstrom. Millie Palladino. Caitlin Balunas. Summer Phillips. Edward Provencher. Michael Ramsey. Angie Rivera. Adam Rowe. Caitlin Smith. Max Snyder. Paris Venus. Emily Wright. Hannah Wyatt. Erica Yan. And Josh Young. First up, I would like to thank you all for attending tonight's ceremony. I would like to thank our guest speaker, Dr. Bulliard, and Mrs. Farley for taking the time to address the group. And I also would like to thank Mr. Freeland for all his hard work and dedication to Mu Alpha Theta at UHS. It was certainly an honor to be elected president by the fellow members of Mu Alpha Theta. Many hardworking, talented, and intelligent individuals make up this group. Tonight, I want to congratulate the 2013 inductees on their academic accomplishments and their selection into Mu Alpha Theta. Now, MAP can be summed up in a 4-letter acronym for some people. Mental abuse to humans. But the students sitting in this room have been blessed with a talent to think mathematically, as well as a drive to work hard. Many of you are going to achieve success and make a difference with your knowledgeable skills. Building bridges, playing instruments, and balancing budgets are just a few of the seemingly endless math opportunities. There is something for each of you out there. But as Ralph Waldo Emerson once said, neither you nor the world knows what you can do until you have tried. I challenge you all to use that gift to its utmost ability to not only reach your dreams, but to make a difference as well. Thank you. Now, if you would please join us for lunch and dessert in the cafeteria. And we thank you all again for attending tonight's ceremony. We ask that the new inductees stay sit for a second. We're going to get a photograph. And thank you again.